Okay, so let's talk about quadrilaterals in the coordinate plane. So remember all those properties where this is just for parallelograms. In addition to the parallelograms, these two properties for rectangles, and then in addition to these parallelograms, these are the extra three properties for rhombus. Well, squares are all these properties. So when we prove these in the coordinate plane, notice these are not on axes, okay? They give you points, they give you information, and they want you to figure out the information that they're given using slope, distance, midpoint, and properties of the quadrilateral. Well, we know slope is your delta y over delta x. In other words, subtract the y's over subtract the x's. We know the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We know that the midpoint formula is basically the average of the x-coordinates, so x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And then you have to remember these properties that we've just talked about. So if you look at number 1, it says on parallelogram, so we already know it's a parallelogram, okay? PQRS. If P is located at -1, 6, and S is located at -7, -3, what is the slope of QR? Well, aren't these parallel? So whatever the slope is between these 2 points, it's going to be the same as the slope on QR, because that's one of the properties of a parallelogram. So basically, we're just going to do the slope formula. So subtract the y's. I'm going to do 6 minus -3 over -1 minus -7. So you end up getting 9 over 6, and then we just reduce that. So the slope of QR is 3/2. So the slope of PS and the slope of QR are exactly the same. Parallel lines have the same slope. Now let's look at, let me make a note. I just realized, remember we talked about in a rhombus, the diagonals are perpendicular. So perpendicular slopes, just as a review, there's 2 parts. They're opposite signs and they are reciprocals of each other. We'll probably use that at some point on the quadrilaterals in the coordinate plane, okay? So, like for example, 5 and -1/5 are perpendicular slopes because the reciprocal of 5 is 1/5, and since 5 is positive, you need a negative slope in order for the lines to have perpendicular slopes. And then, so let's just recall this, and the same thing, parallel lines have same slopes, okay? So I wrote that here on the previous notes because I didn't have room up here. And this is a good reference sheet for all your properties. Okay. So number 2, we know this is a rectangle. ABCD is a rectangle. If A is located at the point 3, 4, and B is located at the point 7, 6, what is the slope of BC? Well, okay, what do we know about a rectangle? There's 4 right angles. So essentially, whatever the slope of AB is, we have to do the perpendicular slope, the opposite reciprocal for BC. So let's first find the slope of AB. So let's do 4 minus, actually I'll do, since both of these are bigger, I'm going to do 6 minus 4 over 7 minus 3. So that's 2 over 4, which is just 1/2. Well, if this has a slope of 1/2, in order to be perpendicular, in other words, to be at right angles, this slope has to be negative, since this one's positive, and the reciprocal, which is 2. You could write it as 2 over 1, but you don't need to. So the final answer is the slope of BC is -2. Okay. Number 3, on a rhombus WXYZ, W is located at -5, 2, and Y is located at 3, -2. What is the slope of YZ? Remember what we talked about with the rhombus diagonals are perpendicular? So whatever the slope of WY, same type of thing, we have to do the reciprocal, opposite reciprocal to find the slope of YZ. So let's first find the slope of WY. Oops. And guys, labeling is crucial because there's so many different segments and points. That's why I put the MWY, because that's your slope of it. So let's do -2 minus -2. Wow, I already know. Okay, so -2 minus -2 over -5 minus 3. Well, when you subtract a negative, add a positive, we'll notice -2 plus 2 is 0 over -8. And if you remember, 0 over any number is 0. Those of you that had me for Algebra 1, we talked about special cases, Hoy and Vux. Hoy is horizontal and Vux is vertical. Well, guess what? Hoy, the O is actually a 0 for the slope. So this is actually going to be a horizontal line. And, well, the opposite reciprocal of 0, or you could even use this, since we had 0 over -8. If I took the opposite reciprocal, it would just be 8 over 0, but guess what? That's undefined. And remember we talked about Vux is a vertical line, and the U stands for the slope, which is undefined. So vertical lines have undefined slope. So essentially, the slope of XZ is undefined. Okay, and you can look at it 2 different ways. If you remember the Hoy and the Vux, anything with a 0 slope is a horizontal line, and, well, it's perpendicular to any vertical line that has an undefined slope. Or just take the reciprocal of 0 over -8, or opposite reciprocal, so it's 8 over 0, which is undefined. Either way. Now look at number 4. On the square JKLM, J is located at, let's see, -2, 5. K is located at 2, 2. Oh, I just realized I better make sure this is recording. Okay, good. Okay, so what is the slope of LK? Remember, squares have all 4 right angles, so we do the same thing. In fact, I'm going to have you do this on your own. So you figure out the slope of JK, and then you have to do the opposite reciprocal to find the perpendicular slope, since perpendicular lines are at right angles. Okay, let's look at number 5. On the parallelogram STUV, S is at the point -4, 1. T is at the point 5, 3. Well, notice they said, what is the length of UV? Well, in a parallelogram, opposite sides are not only parallel, but they're congruent. How do we find length given points? We use the distance formula. So if you remember, this is for length. Okay. So then we're going to do the distance between points S and T. So we subtract the x coordinates. So I'm going to do 5 minus -4 squared plus 3 minus 1 squared, subtracting the y's. Well, that becomes 9 squared plus 2 squared. Well, that's the square root of 81 plus 4. So the distance is the square root of 85. let me just check to see if there's any perfect squares. So if I do 85 divided by 5, what are we going to get? Oh boy, I think my calculator is broken. Yeah, it's broken. Okay. What is that? 5 goes into 8 ones, 35, 17. Nope, so the root 85 cannot be simplified. There's no perfect squares, factors. But like we said, that because these two are congruent, we know that the distance or length, so we'll just say, actually, I'm just going to say VU without the segment signal, because this just shows the length between the 2 points, is going to be the square root of 85. So in fact, up here, I could have just wrote, instead of D, well, I could say D equals ST without the segment symbol, showing it's the length between S and T. Okay, so let's look at number 6. We know this is a square. It says Q is the point 7, 0, and R is at 5, negative 8. Okay, well, guess what? If we're trying to find the length of SR, well, all 4 sides of a square are congruent. So we just need to find the length of QR, and that's going to be, so QR has to equal SR. So we're just going to use the distance formula between those 2 points. So we're going to do 7 minus 5 squared plus, and then 0 minus negative 8. So that's just positive 8 squared. So we have 2 squared plus 8 squared. And that's going to equal the square root of 4 plus 64. So that's the square root of 68. Well, does 68 have, I know you can divide it by 2, 34, and then 2 again, so 4 is a perfect square factor, not 17. Because this is a perfect, we can square root this. So the final answer, there's 2 ways you can look at it. 4 times 17, we can square root the perfect square factor, and that's 2 root 17 for our length SR. Okay. Now on number 7, we know it's a rectangle. And remember, rectangles have congruent diagonals, and they bisect each other. Now it says D is at -1, -1, and F is at 4, -8, and GE is the other diagonal. So basically, DE, or DF is one diagonal, and that has to equal the same length as GE, which is the other diagonal. So just use, I'm going to have you do this, just use the distance formula, and just check to see if there's any perfect square factors, okay? So I'm going to have you do that one, practice on your own. Number 8, on a parallelogram, so we know this is a parallelogram. So we know the diagonals bisect each other, but we don't know if they're congruent yet. Now, A is the point 1, 1, B is the point 8, 5, C is the point 5, -5, and D is -2, -9. We need to find point E. Well, E is where the 2 diagonals intersect. This is where the midpoint formula is going to help. Basically, I'm just going to find the midpoint of one pair of these. It doesn't matter which pair. So I'm going to find the midpoint of segment, let's just do AC. And if you want to check, you could also do it for the midpoint of BD or DB. And as long as they're the same coordinates, then you're fine. Okay, but when you're finding the coordinates of E, we're just finding the midpoint. I'm just going to do this side. So I'm going to add the x's. So 1 plus 5 and divide by 2 for the new x-coordinate, or the midpoint x-coordinate, and 1 plus negative 5 divided by 2 for the average of the y's. So the midpoint, or point E actually, I'm going to say, so point E has the coordinates, well, 5 plus 1 is 6 divided by 2 is 3. 1 plus negative 5 is negative 4 divided by 2 is negative 2. There's your midpoint. Okay. All right. Now, notice they give you 4 coordinates. We don't know what kind of quadrilateral it is. I generally just draw a sketch. We just have to figure out what properties work. Okay. So if this W, X, Y, and Z, and all you know is that W is negative 4, negative 3, X is 1, negative 2, Y is 2, negative 7, and Z is negative 3, negative 8. We need to figure out, well, is it going to be just a parallelogram? Is it going to be a rectangle? Is it going to be a rhombus? Or is it going to be a square? So basically we're going to use my preference to find if it's a parallelogram. I'm going to go ahead and check if I'm going to do slopes. I want to see if this is parallel to this, and if this is parallel to this, and let me tell you why. Because if I find these slopes, which have to be the same if they're parallel, and these slopes, which have to be the same if they're parallel, it's for sure a parallelogram. But then I could also tell if there's a right angle. If there's a right angle, then we know for sure it's either going to be a rectangle or a square. Then I could find like the distances and see if they're all like of 2 consecutive sides and see if they're the same, then it's a square. There's multiple ways you could actually do these problems, and if you can think of another way, please let me know, because this actually shows mastery if you can find multiple ways. And then if it's a rhombus, basically I would find if the slope of the 2 diagonals and see if they're perpendicular. Okay, I like to use slope. That's just my preference because it seems to be a little easier. So I'm going to find the slope of WZ, this side. And so I'm going to do negative 3 minus negative 8 over negative 4 minus negative 3. Well, that's 5 over negative 1, so that's just a negative 5 slope. So I'm just going to label this. This side has a slope of negative 5. Now I'm going to see YZ, or XY. So the slope of XY. So I do negative 2 minus negative 7 over 1 minus 2. So negative 2 plus 7 is 5 over 1 minus 2, negative 5. Well, that's just positive divided by negative is negative. So yeah, these sides are parallel. Check. Now let's just check the other 2 sides. So the slope of WX so negative 3 minus negative 2 over negative 4 minus 1. So that's negative 1 over negative 5. Well, negative over a negative is positive. So this has a slope of 1/5. And I can already tell that there's a right angle here. So it's either going to be a square or a rectangle, as long as this has the same slope. So let's just do real quick before I jump ahead. ZY, the slope of ZY. So these two, I'm going to do negative 7 minus negative 8 over 2 minus negative 3. Well, that's just 1 over 5. Yeah. So right away, we know it's going to be either a rectangle or a square, because these have, all sides are perpendicular, they're opposite reciprocals. So, yeah, let's do the diagonals, because if it's a square, we know that the diagonals are perpendicular. I guess we do have to do, no, we don't have to do that. We already know it's for sure a rectangle. We just don't know if it's a square. So we're going to check if the diagonals are perpendicular. So let's just use slope. I like to use slope. We could use distance formula to see the congruent sides. I just preferably don't want to use the distance formula unless I have to. So let's do the slope of the diagonals wy, and then we're going to figure out the slope of the other diagonal zx, so that if these are perpendicular, we know it's a square. If they're not, then it's just a rectangle. Okay, so check, we know it's a rectangle, but if the diagonals are perpendicular, then it's also a square. Or I should say, instead of also, it's more specifically correct that it's a square. So let's do wy. So I'm going to do -3 minus -7 over -4 minus 2. So that's 4 over -6, and that just reduces to -2/3. And now zx, so these 2 points, I'm going to do -2 minus -8 over 1 minus -3. So that's 6 over 4, which is 3 over 2. Well, guess what? These are perpendicular because one is positive and one is negative, and they're reciprocals. So, since we know that wy is perpendicular to zx and they're diagonals, then wxyz is a square. Okay. Now, go ahead and do the similar thing with number 5. I'll put the answer key up, and like I said, there are multiple ways you can do that. You can do distance formula. Another thing with a square, you could find the length of all 4 sides to see if they're congruent. I mean, any one of these properties is perfectly fine. All you need to really remember is if you're finding congruent sides, you have to use length, which is the distance formula. Okay? If you're trying to find midpoints, or the fact that like the diagonals bisect each other, you'd have to use the midpoint formula on both diagonals. And then to find parallel lines or perpendicular lines, you're going to want to use slope, and that just happens to be my preference. But let me know if you find another way that you think is easier, and we'll talk about it soon.